Greetings, building science enthusiasts, and welcome back to the Building Science Podcast. Today's episode is brought to you by Mitsubishi Electric Cooling and Heating, a modern zoned comfort solution from Mitsubishi Electric Cooling and Heating. Each room can be an oasis with its own temperature control and filtration, and the systems are so quiet you'll barely even know they're running. All you'll experience is comfort, the way it should be, tailored to you. And you can condition only the rooms you want and save money by turning off the rooms you don't. Forget about that old central system and step up to modern comfort. There's a smartphone thermostat, whisper quiet operation, and over 40% more efficiency than central heating and air. Enjoy the modern comfort of zoned comfort solution from Mitsubishi Electric. Modern comfort reinvented.
Welcome to the Building Science Podcast.
Welcome to the Building Science Podcast.
Bringing the human factor to construction, design, and architecture. Brought to you by Positive Energy in Austin, Texas.
Hello, everybody. Hello, and welcome back to the Building Science Podcast. I'm Kristof Irwin here, as always, with my producer, Miguel.
Hello!
And I have a wonderful guest to introduce to you today. I'm here with John Chavez. John Chavez has the illustrious career of having built, grown, and sold a couple of HVAC design build firms in Los Angeles area. He's now a manufacturer's agent, and he and I have spent many pleasant hours geeking out about VRF, and I thought I would share some of that with you guys today. We have a lot of ground to cover, but before we get into the topic at hand, which is how to use VRF, variable refrigerant flow, I want to ask you, John, manufacturer's agent. Can you briefly tell me what that means?
Well, first off, I want to thank you for inviting me. I really appreciate you inviting me here to speak today. A manufacturer's agent is a representative of HVAC manufacturer equipment and components. We are independent, commission-based.
Yeah, that's what I wonder.
Company.
Are you independent of the manufacturer?
Yeah.
Or are you not completely, though, right?
100%.
Okay.
Yeah, we're manufacturer's agent is on a 30-day lease. Any manufacturer can decide to change their business model.
Interesting. And so you support the users of a given manufacturer's equipment.
We promote. We provide market intelligence. We provide technical support or any kind of support to wholesale distributors and to plan and spec firms within the HVAC industry.
Okay, good. So manufacturer's agent, and so I know you have background in VRF because we've talked about it. So first topic we're going to talk about is putting VRF in perspective and putting in perspective particularly of the U.S. market. And you know, we've talked about before on the previous episode. You guys listening, we did a previous episode on understanding VRF, and there was a little bit of background in this, but the bottom line is this is a technology that goes back into the, depending on who you ask, the 70s or the 80s for the basis of it. And it's very popular in Asia and Europe, and that's, well, one reason could be because energy prices are higher there. And now it is penetrating into the U.S. market, and it is replacing conventional single-stage and dual-stage equipment. John, any comments on?
Yeah, so the popularity of VRF outside the United States was driven mostly just by space. You know, the concept of attics really exists mostly here in the U.S. So when you just require perhaps just a 3-inch diameter hole to run your refrigerant tubing, your electrical, and your drain, you know, it kind of opens up a world of conditioning. There. So third world countries, you know, India, you could think about, you know, the Caribbean, you know, it's popular. It's in upwards of 80 to 90% utilization. In Europe, they actually called about 15 years ago when or maybe 20 years ago now, they would call VRF chiller killers. Because, for years, large commercial spaces would use chillers, right? But then, as you stated, the cost of electricity, $15 a gallon for gas, and, X amount, 5-10 times the cost of kilowatt hour. So VRF came in with the inverter-driven compressors, electronic expansion valves and metering devices, which save a lot of
That's great.
money.
Yeah, so VRF, the reason that it's so popular in the U.S. market, it's starting to be more popular, is ironically, it's not the energy play, it's really the form factor play, and the fact that we can get better comfort, or we can have a house that, and we'll get into this during this episode, but we can have a house with one outdoor unit, multiple indoor units, and they can be off for different set points, right?
Or simultaneously heating and cooling.
Yeah, even single
within
phase.
the same refrigerant circuit. You can have, it is possible to have function and form. And the HVAC industry in the U.S. is catching up to that idea. In 1993, in the state of Texas, Mitsubishi launched their ductless systems called the P Series. They only had 2 models. And there was just 2 guys running around saying, it was Gunter Associates and a Mitsubishi employee trying to promote, hey, we have this air conditioner. It's a little unit, stick the outdoor unit, close by, and the indoor unit hangs on your wall. You want me to put what on the wall? It was just unheard of.
That still exists. Yeah.
Not nearly as much.
I
I think right around 2011 is when pretty much everybody understood mini.
No, don't go there, because people are still saying, "What is it? What? Tell me about that." I mean, it's still new to many people.
From my purview, from my perspective, I may not be as granular, in the trenches as you.
Yeah, so there's project teams that it's still new. I mean, that's
as far as contractors are concerned, everybody pretty much knows what a mini split. They may not want to deal with it. They're afraid of it.
There you go. That's where I wanted to take this. So it's 2017, by the way. Whenever you're listening to this, that's where we are. And in 2017, it's still considered somewhat new. And it's one of the most interesting, and I should just be straight and say irritating, industry dynamics is in fact coming right now from the contractors, right? Architects and builders they're happy to have multiple indoor units and smaller duct runs because of that. But we're really getting... I don't know. It's like the fact that we really want to aspire. We want to aspire to no duct board and very limited flex duct, and really, really good quality mechanical designs at the front end. And the perspective we get is something like we're naive, or we're unsophisticated, and we're just too star-eyed, for this utopian future.
You're getting pushback from
installers.
Yeah. Well, if you look from the perspective of the installer, which I happen to have.
That's true.
Yeah.
Why is
they are wearing a lot of hats? When you say installer, I'm thinking owner, contractor, right? They have to be, multiple businessman and tradesmen, and usually you're either good at one and not good at the other. It's rare to find somebody that's really good at both.
Okay.
And so when you say, hey, we have this new fandangled thing that we want you to install and learn about, it's going to be great, and you have all this positive energy behind it, and they're just trying to get through the day.
Yeah.
They're stealing from Paul to pay Peter on jobs. They got checks holding for 180 days, so that's a stressful thing to make changes. And when you just do what you do and you try to get in and out, learning something new is very difficult.
Absolutely. Yeah. And I've had contractors tell me straight up that, if it's conventional equipment, I can just tell that crew, go. That's all I have to say. Go, do what you know. And it is that. It's sort of the hands that do the work are pacing the industry transformation that's pending and it happening. So that's the interesting thing is VRF is taking over the market. Whether it's VRF multi-splits or not is something we could argue. But
taking over the market right now in the U.S., according to AHRI statistics, Air Conditioning and Heating Refrigeration Institute, which is, we looked for many standards and it's roughly around 6% of.
But growing, right? It's the fastest.
It's growing 20% a year on average. Between like 2009 and 2012, it was like more like 35%. So it's cooling off a little bit.
Interesting.
But there are a lot more players in the market too. So
they just go on. I mean, walk the ASHRAE trade show floor, and there's 30 of them easy.
Right.
So today we're talking about using VRF, and we're thinking about both the design and the installation piece. So we're going to talk about the equipment up front, outdoor units, indoor units, and controls here. And then we're going to be talking about the design process, kind of going sequentially through it. So that's a lot to cover. So we're going to start with outdoor units. These are the units that in the summer, the heat that gets absorbed inside your building is rejected outdoors through the outdoor unit. And in the winter, it's the opposite. The outdoor unit collects heat, and it can collect heat down to single digits. I think it's 5-7 degrees. Something like that.
Minus, some manufacturers have equipment that can go to minus 13 and have 100%
Fahrenheit,
heating.
But still, that's amazing.
Fahrenheit, yes, thank you.
Kaboom, that's awesome. Okay, so that's the outdoor unit. It can collect heat from the air, vibrational energy in the air, even at minus 13. That's astounding.
Just a comment on heat pumps.
Please.
This is not your father's heat pump. This is a product that typically a conventional system, a single speed or maybe a 2-speed compressor heat pump starts to lose capacity at around 55 degrees ambient. With some manufacturers, you can get 100% cooling capacity at 0 degrees.
Yeah.
And you can get 100% heating at negative 13.
Right.
There are manufacturers' equipment that they're working on that can go to negative 40. You know? Yeah, so they're VRF and single zone mini split systems are in Alaska, Canada is a big market to Kuala Lumpur,
And just when you say it's not your father's heat pump, the production the indoor temperature, the delivered space temperature is also significantly higher.
Yeah, I've been on projects in Oklahoma where it's 9 degrees and the leaving air temperature out of the unit was 136.
Yeah, we get 120, 130 routinely up here, even when it's very close to satisfying space temperature. It's plenty warm. Yeah. Whereas I had a heat pump in the Northeast in the late 80s, early 90s, my first home, and it would make like 95 degree air. When it would blow across my skin, it was cold.
Yeah, yeah. If it's if the air and
below skin temperature.
Yeah. So
maybe it was even the 80s. All right. So outdoor units, there are several types, and the big fork in the road is single phase, 3-phase. Yeah. Which is typically thought of as a residential commercial bias, but it doesn't have to be.
No, it doesn't have to be. There are plenty of applications where you have 3-phase equipment in a residential community, which generally has single-phase power, and you accomplish that by adding a
phase converter.
A digital third phase. The magic in VRF is basically it's a computer. All the hardware is very well known. You have compressors, you have solenoids, you have metering devices, you have coils, you have sensors, right? These are all things that are off the shelf.
Basic laws of physics.
You're right. Yeah. The secret sauce is the software, and every manufacturer has its own secret sauce. They perform simulations and modeling for fluid dynamics, thermal dynamics.
Some manufacturers more than others.
Agreed. I'll give you an example.
Please.
I was, a couple of summers ago, I was on a roof, 10-story building in downtown Dallas, The roof temperature was like 118. Ambient was like 98, so it was a big difference on the roof. And the whole building is being...
you mean the air temperature at the roof, not the surface temperature?
Well, right, so the street temperature was like 98, but the roof temperature was like 118, so it was very, very hot. And the whole building, common areas, were being cooled by VRF systems. Got a call from the on-site engineer saying, a couple of the hallways are not keeping up. It's like 74, 75.
What did they want them at?
We 72.
Okay.
And we are a little bit uncomfortable. Talked to him on the phone, couldn't solve it. Went down, visited the job site, and walked onto the roof. And I saw a line of outdoor units. Right, they're called like a condenser farm.
Mm-hmm.
And as I was approaching the roof, the equipment, I walked past the equipment, and then I saw a bunch of goosenecks. Laundry vents. And the laundry vents didn't have a bag over it, all of them. And so all the lint was collected on the coils. Yeah. All right. And if you have never seen a condenser coil before, you would think that that's the way it is, because it was perfectly sheened on there. Right?
With lint.
Yeah. And it was about 2 inches thick. But get this, this is the special part of VRF. It was 118 degrees on the roof. It was only 2 to 3 degrees off.
Mm-hmm. And it was wrapped in fur.
That's the software telling the compressor, hey, you're running too hot. You need to slow down to conserve heat, right? Mm-hmm. So you don't overheat. And the condenser fan motor, or the outdoor unit fan motor, was asked to accelerate. On a conventional system, what would happen was that it would shut off an internal overload. Like you would have zero.
Yeah. Mm-hmm.
But with VRF, because of the algorithms, the software, and the components, the secret sauce, it survived that scenario.
Beautiful.
So that's all the extreme.
I just wanted to chime in and paint a picture for you guys that when someone says condenser farm or condensers on the roof, just in a hand-wavy way, what you think about is like a refrigerator lined around the outside on the sides with something like a car radiator, little fins, and then in the middle and at the top of the refrigerator is a big fan. So you're sucking air in through the sides or side, and you're blowing air out the top. So we had these units that need to breathe, and they were getting choked by lint. Fascinating.
Yeah.
Okay, good. So let's start there. So that's one of the examples of the outdoor unit, and that was a 3-phase. And there are 2 main types of 3-phase outdoor units. There are the ones that are heat pump and the ones that are heat recovery. Could you talk about that?
Sure.
Difference?
So heat pump provides both heating and cooling using a refrigeration system. It's 2 pipes from the outdoor unit to the indoor units. It's 1 mode at a time.
Mm-hmm. All the indoor units.
All the indoor units. So if you have 12 indoor units connected to an outdoor unit, and 11 of them are calling for cooling, and the one wants to call for heat,
mm-hmm.
first mode wins.
Mm-hmm.
So if the one is calling for heat, the other 11 will have to wait until that heat set point is satisfied, which is it's a temperature delta and time, because you have to change over the refrigeration system.
Understood. Yeah. But if, let's say, they're more typically, there is some issues on days with diurnal cycles that morning needs heat, afternoon, and then certain zones. It can be a challenge, and it's the controls challenge. We'll talk about controls.
Well, there's like 5 strategies for handling heat pump mode. The first one is you have to communicate it to the users. That's very important.
Yeah.
Because everyone has a thermostat. Mm-hmm. And so in their mind, like, I want this. Mm-hmm. And they push the button for heat, and it's already in cooling.
Yeah.
And it's just flashing, and it's not working, and they think there's a problem. So there's a lot of consternation.
Absolutely.
A lot of
and we've gotten tangled up in it. It's
with
problem.
Not having that initial get up and go conversation. But there are also control strategies. Some are more user-friendly than others. For instance, one of them is you can put an external temperature sensor on the outdoor unit, and at a certain temperature, it will force to go into heat mode or cool mode. You can put a schedule, which is quite popular. You can have a master thermostat. So if you have 12 indoor units,
Exactly.
You can select one of the 12 to control the mode. Some manufacturers even have a 2-button switch that has cool and heat, and you could just push it. So there's many strategies, but the first one is having that conversation. Like, this is just one
managing
mode at a time.
expectations. But so talking about it on the upside is that, like, if they're all 12 indoor units or more,
it could be up to 50.
Yeah. And by the way, let me interject for you guys that this we were talking about 3-phase heat pump outdoor units. Much of what we just said, in fact, all of what we just said so far, applies to single-phase, more residential-based heat pump, multi-split, multi-zone units. But what I wanted to point out is that you can have multiple indoor zones, and all but one of them could be off. They could all be at different set points, granted that you're within the mode of cooling set points, right? One could be at 68, one could be at 78. So the second type of 3-phase outdoor unit, which, by the way, is starting to exist in single phase.
There is one just came out.
Yeah, and it's sort of the clouds part and the angels sing, and now you have heat recovery units, and this means that you can have multiple indoor zones, and anybody can have heat and anybody can have cooling at the same time
in a residential space. Yeah, it is quite different.
Yeah, but in a commercial too, right?
Yeah.
So 3-phase.
Well, commercial, that's where it started.
And these look like, in terms of the form factor and things like the weight and the size.
The technology is 35, 40 years old.
Even for heat recovery.
Even for heat recovery.
Fascinating.
Well, I strike that. It's heat recovery was actually in the late mid 80s is developed.
Oh, that's close to 30 years.
It actually it came in a dream into a Japanese engineer. I mean, at least that's what the lore is. I mean, I wasn't there, but the popularity of simultaneous heating and cooling is. Instead of utilizing a chiller system and a boiler system, a double duct system where you have always hot, always cool air, or water, use refrigerant. And you have an outdoor unit, that's a heat pump, okay? Then you have a box that's in between the outdoor unit and indoor units. They have different names. This box can be called a branch circuit controller, branch selector, mode change unit, heat recovery unit. What they all do, though, is that they provide a method of bringing in a liquid or vapor refrigerant, depending on the mode, using the one outdoor unit. Different manufacturers have different strategies for that.
Yeah, I don't think we need to go into the branch box. It is fascinating.
Yeah, well, there's 2 pipe.
It's where the magic
and
happens.
There's 3 pipe systems. So they're really different. Even though to the end user it doesn't matter, but to wonks like us, there is a striking.
Is one generally more reliable than the other in your opinion?
Okay, this is strictly my opinion. Okay.
Strictly his opinion, everyone.
Based on attending 7 manufacturer trainings, multiple times.
Yeah, and multiple job site visits.
A 3-pipe system has low, medium, and high pressure refrigerant running through it. It is a heavily engineered refrigeration system, typically using hard pipe. So when I say hard pipe, it means that you have to braze many connections, and that offers its own challenges
and costs.
And costs. But when I say heavily engineered, you have to have specified piping diameters at certain locations.
We've done it.
With the 2-pipe product, you can use soft copper after the mode change unit. It's just one size. You size it to the indoor unit. So for an installer and first costs, that.
So 2-pipe actually.
2-pipe, yeah. You're going to generally use more pipe in a 2-pipe scenario. However, you don't pay. You order copper by the foot, but you don't pay for it by the foot. You actually pay for it by weight. So you may be using less copper on a 3-pipe, but since you have to use hard copper, it weighs more. So actually copper costs are
interesting.
more.
And then there's the cost of all those brazed fittings and
the liability, right? Because if it's
one goes wrong,
if it's not properly tested for leaks, which is typically a 24-hour hold with high pressure nitrogen, it can down the road you can have some problems.
So there's so much to say about outdoor units. I'm gonna try to recap and then get us going. So we started out talking about 3-phase heat pump, 3-phase heat recovery. That's what we've done so far. Those are also available with water-cooled systems, right? So instead of the system either getting or shedding, sinking or sourcing its heat from the air, it can do the same thing from water. But let's leave it at that. And let's go into single-phase equipment, which more traditionally, more commonly thought of for residential and light commercial.
It's 60% in the market.
Oh, interesting.
Yeah, so it's a 60-40.
Okay, and so I see within that within that product sector, I split it into 1-to-1 and 1-to-many. But there's so many names here. Could you just talk briefly about the names? But
sure. So
try not to get bogged down.
Some people call it ductless, which is like an overarching.
So now you're talking about 1-to-1 is ductless, or both?
1-to-1.
1-to-1 is called ductless. Okay.
Yeah. So
even if it has ducts, it's
even
called
if it have ducts, and that's
Okay.
that's the way it is.
Okay.
Some people say inverter ductless. Some manufacturers have chosen to say duct-free splits, ductless split system. In the South Pacific region, they call it split klima.
Split klima.
Yeah.
Even if it has ducts, though.
Exactly. Mini split, single zone, 1-to-1. These come in heat pump or just straight cooling. And then you have a multi-zone system. 1-to-many. Typically a minimum of 2.
And by the way, excuse me, interrupt, John. When we're saying 1-to-many, we're saying 1 outdoor unit, many indoor units. Just making sure we're very clear on that.
Up to 12 indoor units.
Typically for single phase.
Yeah, and the differentiators between a VRF system and a ductless system is electrically, single phase versus 3-phase. Okay, but also where the metering device is.
That's a big one.
Yeah, so in
metering device is where the refrigerant is turned from a liquid to a vapor and begins to absorb heat.
Correct.
That's in cooling mode.
Yes, that's correct. The metering device in ductless systems is typically in the outdoor unit. If it's a multi-zone, it can be in the outdoor unit, or it can be in a separate box closer to the indoor unit. But the indoor units do not house the metering device. And also...
On what type of unit did you say that's for?
A multi-zone.
Multi-zone.
So you can have perhaps up to 5 indoor units connected to the outdoor unit, but anything over 5, visually and what the outdoor unit can house, it can't really house that many metering devices, so they put it in a box. And the box could have 3 to 5 connections.
Or 8.
You would get a 5-port, and then you buy a 3-port, so it'd be like 2 boxes.
I think we're getting deeper, because I'm trying to stay at the higher level on the outdoor units, because really the indoor units, John, was where
let's talk about the indoor units.
Take our audience, but let's wrap up that outdoor unit. So because I want to just say that I was talking to a manufacturer recently that used what John just talked about here is where the metering device is as being why you call it a mini split. So if the metering device is at the outdoor unit, and what you need to realize is that then your refrigerant line going inside in the summer, let's say, is cold all the way from the outdoor unit to the indoor unit, versus if the metering device is in the indoor unit, then he would call it a multi-split.
Yeah.
So it's interesting. Mini split was metering device outdoors. Multi-split was metering device indoors.
I'll buy that for $1.
But there seems to be no standardization, and that keeps us consultants and engineers like us in business, I guess.
There are not a lot of conventions at this level of discussion.
And so this is actually, so the fact that it's a bit of a tangled mess with nomenclature and that there's many options is what you guys should take away from that. And John and I really could have gone deeper into the various manufacturers' nuances and changes on that. But when the rubber meets the road, let's just talk about there's something outside. It's connected to something inside with refrigerant pipes. And it's really this palette of colors that opens up when we have these indoor units, that there's different form factors, there's different ways to deliver heating and cooling to the spaces. And I think that is one of the key takeaways you guys need to, or will benefit from on this episode, is using VRF means you have these different types of indoor units. And let's start with the one that makes the naming thing seem crazy. There are some that are truly ductless, right?
Yeah. So ductless just refers to the absence
of a duct.
of ductwork.
Unless it's referring to the whole class of equipment called ductless, which has ducts.
Yes.
Couldn't resist, sorry.
I apologize. It's
But
just
truly
the way it
ductless
is.
means no ducts.
That's right. So there are a few different styles of indoor units
That are ductless.
That are ductless. You have the high wall version, which sits generally anywhere from 8 to 14 feet above finished floor.
And these are the ones that send people screaming from the room because they're so ugly, right?
I see only the beauty in them, but
Yeah.
yeah,
Thermodynamically, they're lovely machines.
they can be aesthetically pleasing. There are manufacturers that have different coverings, colors.
Picture frame model.
Yeah, that's a lot of variations available. There is ceiling mounted units, which refer to as ceiling cassettes or four-way cassettes, which is a concentric type vent. You have the return in the center in a grid. Then you have 4 outlets on the perimeter.
And there's within there, excuse me, it's an important point here. There's a couple different sizes. Typically, there's a 2x2 square, which everyone wants, except for when they realize, well, to service it, you need an adjacent access port, because the 2x2s are typically designed for grid suspended ceilings, and it's going to be in a 2x2 suspended ceiling grid. So they're like, okay, look, you can just pop out an adjacent tile. So if you have a residential with a sheetrock ceiling or a commercial with a sheetrock ceiling, you got to say, no, there's an access port nearby. But then there's the 3x3 or the 30x30.
Sure. So
it has access all through its own.
The 2x2 version typically ranges from 9,000 to perhaps up to 18,000 BTUs.
So that's 3/4 of a ton to a ton and a half.
And the electronics are housed externally. Okay, the filter is accessed from within the space. It fits nicely into a T-bar ceiling.
That's what they're called, T-bar ceilings.
And in a residential application, you would just make sure that the electrical box is accessed from the attic or from some type of access door or something. On the 3x3 version, typically that's going to be from 18,000 to up to 48,000 BTUs.
Ton and a half to 4 tons.
The electronics are within the return air space, so everything is, including the refrigerant piping, is accessible from within the space.
Right. You just take a ladder up to the unit, pull your grill.
Right. They have, they both have internal condensate pumps and safeties. Yeah.
Okay. Then
you have under the ceiling version.
Yeah, please keep going.
Which you can mount flush to the wall. The return is directly underneath.
So it mounts on the ceiling, but it's actually completely below the ceiling. Whereas the other ceiling cassette, there was a grill on the ceiling,
flush mounted,
but the business end was above the ceiling.
Right. So.
And how tall are the business ends? I'm sorry, I'm going back a little bit.
That's fine.
The ones that are above the ceiling, you have the ceiling, you have your grill, and then you need what? 10 inches, 12 inches, 8 inches.
It typically between 10 and 12 inches.
Yeah,
something
the smaller
like
ones
that.
are a little lower.
It's not very much. Which, one of the many benefits of VRF and ductless systems is the flexibility in its design. When you're designing an HVAC system, you can choose one style and another style for a different space, and a ducted unit, all on the same refrigeration system. There are perhaps up to like 8 different styles.
And so just one caveat here, I'm thinking about a project we did. We did one project where the whole house, very modern looking house, had embedded ceiling cassettes in it, and it's been fantastic.
Yeah.
But interestingly, they were considering doing like these faux beams on the ceiling, sort of these old craftsman style beams, and we had to remind them that that was going to dramatically impede airflow because we're blowing sideways from the ceiling, and they were going to box us in, with these 12-inch beams. So you got to be careful.
One of the benefits with having an air conditioner that's basically a computer is that you can program the opening vanes
to aim down on
to aim down. Yeah, that's it's a very intelligent system compared to conventional.
And in fact, there's usually 4, blowing off in cardinal directions, let's say.
On the cassettes,
4 directions. And you can abandon one of them and run a duct to an adjacent, let's say, bathroom or something like that.
Yeah. So a ductless system
well, you just
does
put a duct
not
on
have external static pressure. Okay. So, meaning that to add a duct, you have to abandon one of the vanes, in this case on the 4-way cassette, and make sure that you put some type of insulation so it doesn't condensate right there, and then run a duct. I would recommend maybe up to 8 feet, and it's going to be a 4 or 5 or 6 inch duct max.
I understand.
You may need.
It's for a small auxiliary space.
Yeah.
But that's very useful sometimes. Someone puts it in their bedroom and they don't want a whole separate unit for their bath or their master closet.
Yeah, this technology is all about opportunities.
Yeah. All right, so let's move on. So that's the space-mounted ceiling, and then you were discussing that there's some that are on the outside of the ceiling.
Yeah, under the ceiling version.
Not those have really long throws sometimes.
Very long throws, like in up to 30 feet, unobstructed. Okay.
Yeah, there's a bar down on 6th Street in Austin. I can't remember the name of it now, but it's a long, skinny space, all one floor. And when you walk in the front door, it would knock your hat off, if you had your cowboy hat on. And
that's exactly what
it's handler way back there hitting me in the head when I walk in.
Yeah. That's exactly awesome. What I would design it in for. It's a scenario like that, or so. There is another style.
That's more commercial, probably.
That is commercial, yeah.
Industrial.
Yeah, but some manufacturers offer it in their single bays.
Yeah, I know it's offered, but like architects typically and homeowners nah, I'm not going to have that hanging off the bottom of the ceiling.
Yeah.
Then there's this what I call radiator style unit, which are wall-mounted units or floor-mounted units. Yeah.
Yeah.
Oh, I'm sorry, I shouldn't say wall-mounted. Low wall mounted.
Yeah.
Yeah, so one manufacturer, Mitsubishi, has one of those.
Other manufacturers have those.
That's right,
too.
several of them have.
Yeah.
So low wall mounted. But then there's truly radiator style that sit on the floor and they can be in the middle of a space.
Yeah. I did a project in Culver City on a historical building which had radiators, and I took out all the radiators and put in the
heat pump.
Well, no, put in the indoor unit that fit in that space.
Awesome.
Used the old iron grill.
Oh, neat.
Right. Found an artisan to make a.
You bought an artisan?
No, I'm sorry. Strike that. I found an artisan to make an iron grill that would somewhat match the original grill for the supply vent.
Very cool.
Yeah, it was awesome. I mean, it's, I don't get to be creative much in this industry, but when I do, it's like this.
Yeah, it's one of my favorite things. We work with a lot of architects and really trying to find that blend between elegant thermodynamics and elegant aesthetics. It's tremendous. But I want to make sure people are aware that on these radiator style floor mounted, let's say floor mounted, that's the proper terminology. The filter is at the bottom. They suck in air through the bottom, so you have to provide access to the bottom. Oh, or the side. Yeah. Different manufacturers.
Yeah, they blow from the top or the bottom. So there's different styles.
So it depends on manufacturer.
Depends on manufacturer and the style. The residential style is going to be the low wall with the return entering the side and blowing from the top or the bottom or both. The commercial versions, it's going to the air enters from the bottom and exit either from the side, or it's convertible, or from the top.
Okay.
Right.
So we've used the ones a couple of times now, or 3 times now, and it's really a clever solution that people go, wow, that's what we're looking for. So you have a big living room, dining room, kitchen with one contiguous volume, and there's, let's say, a bank of cabinets separating the kitchen from the dining room. So just built into the middle of the space.
Yeah.
And what we can do is, in the middle of that bank of cabinets, we can have this floor-mounted unit that's pulling air in the bottom. And now we cheat a little. So instead of blowing directly out of the top, we go up like 6 more feet or 4 more feet, and we blow out of the top of the cabinets.
Sure.
So suddenly in the middle of a space, I have refrigerant line, electric line, and condensate line, and I have an air conditioner in the middle of the space.
So the external static pressure of those models is very weak.
I know. There's no. In fact, it's
so
not
if you're
spec'd.
going to put it inside, if you're going to recess it, because you have exposed versions, which are going to paintable cabinets or.
Right.
And then you have the recessed one, which you're referring to. You would want to put a duct system with vanes and
everything you can to get
everything
the air out
you can
easily
to
without
reduce the
resistance.
pressure
And that's
drop.
what we've done.
But I've seen these beautifully installed in old churches in New Orleans. Churches everywhere. This
VRF is
technology is popular with churches.
Because it's very quiet.
Well, they may have a 30-year-old chiller in there, and the pastors get together in their conferences and stuff to talk about, what's going on. Oh, I'm saving 30-40% electricity because of this technology.
Because of the
And we
chiller
want to
killer.
hear that, right? They're a bit, I don't mean to offend anybody, but it is somewhat of a business because they have costs. They have things that they have to pay attention to, and when people
the spiritual and the secular are connected.
So VRF is very popular with those historical buildings. The northeastern corridor of the United States is the most popular area for VRF because of the building styles. You think about basically
They all
it's
had radiators.
European.
Oh, and you're right,
style
more European influence.
buildings. Yeah, so. They do 3-4 times as much in sales as other parts of the country for VRF because of there's not a lot of free space. So having these different indoor styles offers architects, interior designers, and building owners to have a choice of the style that they're looking for, and then you have the ducted style.
Yeah, there you go. So that's
the ducted
two
style.
different main types of ducted styles.
You have 3 different. They're all ducted.
Well, how do you say 3 different? I say compact ducted and conventional size ducted.
Okay, I'm talking mechanically. There are 3 different external static pressure models.
Yes.
Yeah, you have your
3 different static pressures.
your low static, which is going to be your slim model. It's perhaps 8 inches tall, 30 by 30, something like that.
Pizza box style, we call it.
Yeah, I mean, it could fit, in the smallest of places. It's a fan coil, so it can be in hotel room. Right when you walk into the threshold of the room, you put it right up there. You can, but it's you don't want to add a lot of duct. It's very low pressure.
Right.
You're not going to put a MERV 16 air filter in this. Right? Because no air would blow out.
So I want to make sure I interject here on behalf of the people that are still going, what? So there's external static pressure. There's basically low, medium, and high static pressure. And the simple and relatively accurate way to translate that is if your unit can only handle a very low amount of static pressure, you just need to think barely any ducting, and very little flow resistance with the filters. So medium static pressure, you can handle a medium amount, and then high static pressure, you can put a fully ducted house with a nice filter on that typically. You still need to do fluid dynamics and careful duct design.
Well, the main thing is that you want to be engaging somebody who understands that. You don't necessarily need to understand. You conversationally, but the person that's more interested, or the user, is going to, I want this style, I want that style. The mechanical engineer or the contractor.
Absolutely. And so just to make a quick story, in 2010 I was a builder here in Austin, and I was advocating for putting these mechanical systems into my own projects, and I was getting contractor after contractor, and I mean like 4 or 5 contractors saying no, I won't do it. And it was because they had these low 0.2 inches of water column or 0.12 inches of water column static, and they didn't trust themselves to design ducts for it, right? And I trusted myself to design that. So I'm like, well, how about I design the ducting? And they're like, well, you're the builder. And I'm like, well, I'll take risk. And I signed a waiver and got a contractor to do it. And so it's interesting. The contractor community was like, no, just no, I won't do it. I'm like, but I want you to do it, and I'll pay you to do it. No.
Yeah.
It was just striking to me.
The
But that's
whole
shifted
get
now.
a 3-quote process is conducive for finding a price, kind of. You should really have 12 prices, right?
Oh, great.
But you want to select a contractor that is engaged in the HVAC community. A great way to select a contractor is just to call your city building department and say, who do you like? Right? Because they know the guys that, are confrontational, or they know the guys that are professional, that are Johnny on the spot, as it were, So that's a good filtering process. Another filtering process would be contractor associations. Typically, if a contractor is going to be paying, hundreds or thousands of dollars to belong to an association, they want to engage the community outside. They're not isolated or in a silos.
That's a good point.
Generally speaking,
And ask. Well, you could ask us here, but you could ask builders and things like that. So
yeah,
we get a good perspective working through. All right, so good. That's an interesting little side point. How to find a contractor. But we were talking about ducted, and you went into compact ducted, low, medium, and high static pressure, right? Because there's also standard form factor, and standard form factor, as we've talked about on the other episode, it's more what people are used to. It's this roughly 2 foot by 2 foot by 4 foot tall heat pump box, and it has a filter that goes on one end and air that comes in and goes out. This has been where we have found a lot of traction with contractors. They get it. It's a box, refrigerant,
it's
condensate,
familiar.
electric. It's familiar. And what's really been beautiful or appreciated by us over the last few years is that the manufacturers are offering more and more different sizes and different product lines with more of this type of standard form factor option. That's been a benefit.
So what's interesting to me, I don't know about everyone, but it's interesting to me that this particular, it's called air handler typically, was developed for the U.S. market. It doesn't really exist outside the U.S. because we're a ducted nation.
Ducted nation.
Yeah.
Sounds like a new reality TV show.
Perhaps it can be. They have everything for
I wonder how many HVAC geeks are out there.
HVAC wars.
HVAC, yeah.
But, if you have an existing conventional system, right, and you are doing some improvements in your house, or you're building a new house.
Yeah, there you go. You got that box.
Yeah,
it with another
it
box.
fits exactly, like for like. But you're getting a very smart, computer.
A computer with lungs.
A computer, that has some excellent opportunities for energy saving and super.
And so the computer is doing
quiet.
power management, refrigerant management, and airflow management all the time. Kind of like a new car would, right?
Probably not airflow management, but
It does have fan speeds outdoors and in that it can change.
yeah, but
The
manufacturer doesn't know what kind of ducting.
You're
it's,
right. You're right.
So, but definitely in the refrigerant, basically if you think about a refrigeration system, if the compressor is running and performing well, it's happy. Okay, the whole system's efficiently running.
Yeah,
okay?
that's where the sophistication is on the outdoor unit.
Yes.
I'm sorry. Most of it is. It's sophisticated everywhere. That's where the brains are, and a lot of the thermodynamics is happening out there.
That's right, and that's where the logic lives.
There you go. That's what I
Yeah,
say.
because if you remember, we talked about multi-zones. It's basically one-to-ones.
The indoors don't know that it's multi-zones. They just know.
They just know that
refrigerant. Give it to
space
me.
with that thermostat in the space. They're sensing the temperature and the demand in that space. But the outdoor unit needs to manage all that, and the outdoor unit houses the CPU, the logic, the pump, the heart of the system.
That's true. The refrigerant. Yeah, let's talk about refrigerant, and then let's get into controls. Refrigerant piping is actually another differentiator in terms of the single-phase, three-phase split, right? With three-phase, you get much longer refrigerant piping.
Oh, yeah.
And with single-phase, you get
Several
shorter.
1,000 feet.
So there's a lot to say about refrigerant. Let's just keep refrigerant piping mainly to a short discussion about lengths. Could you talk to us a little bit about how long we can go between the outdoor unit and the indoor unit?
Sure. So, and this is generally, the outdoor unit connection between, now we'll talk about heat pump. You can have a total of maybe 1,800 to 3,000 feet, depending on the manufacturer.
Which three-phase or single?
Good question. I was talking about both. I'm just trying to make it concise.
Okay. Because I know some of the single-phase can't go 1,800 feet.
Up to 1,000 on the single-phase.
Or up to 500. I mean, it depends on which manufacturer, which size.
Yeah, that's right. So, basically, if you're looking from a design standpoint, it's just opportunities. Where do you want to put the outdoor unit? You want it to run it underground, way in the backyard, hidden away from everyone? Well,
you can do that.
Mm-hmm. Yeah.
There is a performance hit.
If you have a mechanical
but not a big one.
space, this is where all the mechanical is going to be, right? I mean, I worked on a $25 million home in Bel Air that had 50 tons of air conditioning,
Wow.
Yeah. And, they had a mechanical room and everything. So the distances can be very helpful, but you're absolutely right. The closer you are to the indoor unit and the outdoor unit, the better. You just because you can doesn't mean you should.
Yeah.
So if you want an efficient system, and utilize what the inverter technology and all the wonders of the system, try to bring the outdoor unit as close to the indoor units as possible. Otherwise, you may have to upsize the outdoor unit, which adds to the cost.
Exactly. Yeah.
Now, you have different sections in the refrigeration system. You have the outdoor unit to the first connection, then the first connection to the other connections, and those all offer different limitations and restrictions.
And then there's vertical height.
Depending, there's vertical separation.
Yeah, I was trying to avoid making it complicated, but it gets complicated. There's no way around it.
I think it's just me. I mean, I just
wired to see complexity.
Yeah, it's
terrible.
Yeah.
So generally
full
speaking,
of trivia.
I mean, as a designer, I'm lucky enough to attend design meetings probably 2-3 times a week, and single-family residential. That's typically what we do, custom homes, and there's almost never a case where I have to throw a flag on the play and say cry foul. Like, you can't put that unit there because of a refrigerant line restriction, because of what people are used to with conventional equipment. They kind of plan for that, and VRF can accommodate that. What they don't know is, well, actually, you could have moved it a lot farther away. As you just said, you could put it in the backyard. And because it's an efficiency hit, and because of the possibility of future maintenance issues, or, how do you deal with a buried refrigerant line? Do you really want to trench your yard if you need to dig it up, that kind of thing. So I usually don't say, you could push it 50 feet farther away, 100 feet farther away if you wanted to. Yeah. Just I leave it at that. So typically it's not, refrigerant line constraints are not driving the design, or not constraining the design.
It is something that the designer should be paying attention to.
We know that
another
stuff,
differentiator between the mini split ductless technology and VRF is the manufacturer's utilization of software. So with VRF, you can predict its BTU output based on line lengths and design conditions, which is key, because you're essentially selecting the equipment. I like to call it software that's an integrity check, right? Because if you do something that's prohibitive, right, your design has X amount of feet and locations of whether, then you input that into the software, you'll get an error message if it's outside of the system's capabilities. So
and
mini splits generally don't offer.
Some manufacturers have that, but generally you have to go find through a Byzantine search process the right table in the right expanded performance.
It's not that
data.
hard.
No, I know. I'm kidding. But you do have to know where to look and derate your equipment.
Who to ask.
Yeah, or who to ask. There you go.
Who to ask,
So
you cannot have too many friends in the HVAC industry. And that's probably, true in any business, but,
that's a good point.
Yeah.
So who to ask, it's popping into my head something I think was germane to talking about the installer base, and it's qualitative, but it's almost as though there's personality types or there's an input of where a given installer feels that they are within their career, if they're gradually sliding into the sunset or if they're like young and hungry getting into it, because that's what we kind of have. Is a lot of the resistance to VRF seems to be like, look, I don't really want to deal with all this new stuff and program my machine with my laptop and
Well, everything.
But it's just a mindset. It's like a worldview almost.
Yes, it's psychological.
Psychological. That's the family of origin.
When you're a consumer, you buy things in your mind before you physically buy it. When you make a change, you have to accept the change in your mind before. So if you go to somebody that with a new idea, and you don't deliver it in such a way that is easy, soft sell and let them think about it, and then encourage them. Give them time to, if it's just, hey, I got this job, it's this technology, you've never done it before, can you bid it? And it's like, I'm scared. I don't want to get involved with that because I feel like I'm going to screw it up or I'll lose money is really what they're,
risk money.
Yeah.
Yeah. I mean, I have
but I took the
respect.
dive, in 2000.
What do you mean you took a dive?
Well, my career was 90% airside, conventional systems, and maybe 5 to 10% ductless for most of my career. The first mini split I installed was 1995. But as soon as I looked into ductless and started to see the potential, I switched my business model.
Awesome.
I sold a bunch of cars, got rid of a bunch of employees, sold, different assets, and just consolidated. I became a nice, efficient mechanical contractor that specialized in ductless and VRF. And, my world changed for the better.
Awesome.
My return call ratio basically just disappeared. My employees
you mean by complaints or service?
Yeah, so there's if you install 100 systems, you may get conventional systems, you may get 10% return calls, and that's money lost. You're not generating revenue. But with this technology, if it's installed correctly and you follow the steps, you don't improvise, you just follow the steps, it doesn't break. And
it warns you when it does, and then,
it can send you a text message. My installers' morale increased, because the complexity of a conventional system it's much higher than the complexity of a multi-zone and mini-split system. And let's say that you have a 3-bedroom house.
You just said VRF is less complex.
I'm talking about the whole system.
Tell me.
The whole ducted system.
Go into this. This is good.
So I did an evaluation, right, where you have a cut-in, which generally means you have a house, let's say it's 1,200 square feet, it has a floor furnace, right? And you're cutting into the ceilings to put in an air conditioning system, both heating and cooling, all right? So it's called a cut-in. And to finish that job, it's about 500 steps. Okay, to do that same job with ductless, it's about 75 steps.
And do you mean actually ductless or just smaller ducted systems?
Well, no.
Wall
hung units, yeah. Because
so truly
they're
ductless.
Yeah.
Ductless. That's what we should call it. Ductless.
Oh no. But so the system, the conventional system components are a lot more than a ductless system. So you have on a ductless system, you have less time on the job, which people love.
Cutting smaller holes.
Yeah, you have no hot work. essentially, because there's no brazing. It's all flare fittings.
You got electric, refrigerant line, condensate. That's it.
That's right. So
last topic is going to be controls, and oh boy, how can we do a succinct summary of controls, John?
I don't know.
Is it possible?
It is. I'll do my best.
Okay, go. Let's say 5 to 10 minutes. I challenge you.
Ask me questions. I think that's
okay. Good,
and I'll keep the answer
short.
short.
Actually, that's a really great way to do it. So the typical scenario for controls is we do, Positive Energy does an owner intake meeting, and we get to know the owner. We get to know their personality, and we ask them, how do you want to interact with your mechanical system? And many of the younger people, let's say, I'm not going to pick an age. I don't want to date somebody because it just depends on how you embrace technology generally.
That's very true.
You can control these systems off of an internet-connected device, generally speaking, across the industry now. And that's changed somewhat rapidly over the last few years. So let's start talking about that. Like, when you're controlling from an internet-connected device, you can still have, I'm trying to think of a question, I apologize, I'll get to it. You can still have a wall unit, you can still have a unit on your wall that's Wi-Fi linked, and it gets complicated because the unit, the air handler, it can sense temperature at that wall where the controller is, or it can sense temperature at its own return. And sometimes people don't realize, well, I've got this Wi-Fi linked wall unit that actually I can take off the wall and put on my copy table or on my mantle or on my night table next to my bed.
Or have it on your phone.
Exactly, or have it on my phone. But we'll find, maybe a comfort complaint because the unit is running and getting too cold. And we go and we're like, oh no, what's going on? And we find out that it's just a control setting, but the control setting has been set such that it's measuring space temperature at this wall controller instead of the phone, right? It's at the wall controller. And that wall controller was in the laundry room next to the dryer.
Yeah.
And it does, it's supposed to be in the living room where
Sure.
people are, so then it's hot and
yeah. So the installer or the construction manager should have a conversation with the occupants and show them how to operate, having that conversation, engaging the buyer of the equipment, that's spend, more money on this technology than a conventional system. They deserve that extra time the thing about wireless controllers is that if you put, like you said, if you put it in the wrong space, well then it's going to be sensing that hotter area away from the return or what have you.
Yeah.
It's not getting that mean temperature. And if you don't set it up properly, maybe you're sensing from the indoor unit, and you don't want to.
Right. And if you do sense from the indoor unit and it's on a 14 or 12-foot ceiling, it's going to be hotter up there than it is down here.
Yeah.
So you want to set a temperature delta, which can be set on the remote to tell it, look, shut off when it's 6 degrees above
Sure.
set point.
To circle back around, though, generally controls, there are 3 levels. You have your local level, right? Your zone control, which can be handheld wireless. It could be a wall-mounted, either wired or wireless, or you can have Wi-Fi, off your phone or what have you.
Beautiful.
Okay, so that's zone control, and typically a wired wall-mounted can control up to 16 indoor units, and that's throughout the ductless industry. That seems to be a pattern. So you can have one wall-mounted controlling multiple systems. If the unit is on the wall or in the ceiling, you're going to get a handheld wireless remote that comes with the unit.
Like a TV remote.
Like a TV remote, right? Basically, if you have a Wi-Fi, you can control all the units or a single zone off of your phone or a mobile device, computer,
iPad,
yeah. Then when you move into a level 2, that's your central controllers, right, where groups all those units for all the indoor units or zones. You can have maybe up to 500 zones, right, on a centralized system.
And generally speaking, this is a commercial paradigm where you,
Sure.
or a very big residential project that it really wouldn't warrant. Let's say my house,
Yeah.
one zone,
Sure.
one air handler. There's no point in having a central controller.
No.
Unless I wanted to do crazy shenanigans, and they're not cheap. I mean, they're $1,500 to $2,500 or more for a central controller.
Yeah. Well, and that's just for the controller. There's also the wiring loop that you have to put in.
Mm-hmm.
Then you have level 3, which is integration
with
So-
home automation systems. Or
Yes.
building
So that's
automation
and with some manufacturers, you need to have a central controller.
right to get into Crestron. Or,
Yes, exactly. BACnet or LawnWorks, which can also control your lights, your landscape, fire safety. It all could be in either controlled by the VRF equipment.
Isn't that interesting? Yeah,
Or
VRF could be your controller for everything.
Third-party integration, yeah. So the controls is quite fascinating. A lot of people don't understand it.
Yeah, and it also is very dynamic right now.
Yeah.
The number of controls and the...
And I'm not a computer guru, but I do enjoy electronics, and so the controls aspects of it, it's nearly endless, and that's the future of where VRF is going, is being able to do more. You buy manufacturer X, and it can do what Crestron is doing here, audio and visual.
Absolutely.
And all safety and everything. So it's
Good. Yeah, it's interesting. Tangential. We are very fortunate here at our office, right? We have VRF, a forced air system. We have a radiant ceiling panel system. We have a dedicated ventilating dehumidifier, and we have an ERV. And we're thinking about working with this professor at UT. Actually, I could say Zoltan Negi. He was on. We interviewed him a while ago. To take a person and to put biometric sensors on them, and to use this combination of radiant, forced air, ventilation to make this person healthy. And it's a very complicated control system. So you could really see the future of building controls where it's like, oh, wait a minute, let's not worry about the condition of the air per se. Let's worry about the condition of the occupant.
Yes.
Base my controls on that.
Get into self-learning algorithms and all kinds of wild stuff.
I just love that. I mean, the next 50 to 100 years are just going to be amazing.
You guys both, you guys can't see here but both Miguel and John have, I guess they're iWatches or something. Fitbit.
I got an Apple Watch.
And you have an Apple Watch, John, Miguel. So, right, those are communicating with the outside world.
Yeah.
And why not
Sensing my
have
heartbeat.
a thermal sensor, on the back, and that's saying, I don't have to wonder if John's hot. I can measure if John's hot. And change
With the
thermostat.
advent of understanding what materials can do, your clothes will definitely be able to do all that. And that's where this gentleman, I think, is heading.
Nanotechnologies.
Yeah.
And that's awesome. Okay, so that's a good... Yeah, it's third-party controller integration is probably a good place to wrap up the controls discussion. So we covered a lot in this episode. We covered outdoor units, indoor units, host of topics built in. Any final thoughts before we end part 1 here?
I really appreciate what positive energy is doing, what it represents. This is sorely needed within our industry.
Well, thank you.
And, I'm a big proponent and advocate.
All right, well, I'm not going to argue with that. Yeah, okay. Thank you guys for listening. We'll be back at you next time.